start streaming. We are going to talk about an iPhone 6 here that I think might be interesting. So I thought I would throw up a stream. I haven't fixed it, but I have an idea what's going on, and hopefully you guys will follow along and maybe learn something. So let's see if I can make sure my stream is going, and then we'll hop right in. You are live. The internet can totally see you now. All right, that looks like it is working. So the title of the video is iPhone 6 not charging, not TriStar, and not Tigress. And for Pleasebro Solutions, that kind of is the end of the line. Like, okay, then I guess it can't be fixed. But for this one, I want to kind of dig a little bit deeper because this was a walk-in repair, and walk-in repairs for local people. I want to try to get this guy a good result because he's a hometown homie. So let's try to see what the deal is. So I've got the board here. It is not water damaged, and this seems like it should be a classic presentation for TriStars. Is this guy's son's phone, and he does not deny use of non-Apple chargers. He has no idea what charger he's using. And if you've seen the chargers that are down there at the gas station, they look pretty TriStar burning chargers. So I'm going to stick a screen on here, and we're going to start with seeing what the behavior is now. So this is one that came in during course week, kind of in the middle of the day. So we threw a TriStar on it, but that did not solve. And we then changed Tigress just kind of while he was standing here, and that also didn't solve. So that kind of put it into the needs more thought category. All right, so it looks like we've got some folks coming over to watch the stream. A bunch of hellos from Germany, Denmark, and all over. So I'm going to connect a battery, and I've got screen, board, battery, and dock. Next, I'm going to connect it to our trusty USB ammeter, and it's going to tell us what's going on as far as pulling charging current. So normal charging current is like 1 amp, and on this phone it doesn't do that. It is 0, a big old 0. And it also is not showing me anything on the screen either. I'm not sure if that battery is charged or not, but we'll kind of take that for what it's worth. All right, so now when I looked at this earlier, I noticed that it seemed to be getting hot at, somewhere on the board. So everybody's got their sort of favorite way to detect heat and therefore partial shorts on the board. My favorite way is not the FluorCam, and it's not freeze spray, and it's not alcohol. The go-to method is to use your face. Your face. That is the extremely sensitive short detection tool that I think is fantastic. So I'm just going to put it on the side of my face. And I don't feel like it's getting hot right now, so let's see if we can change that up a little bit. See why it's not getting hot, because it certainly was getting hot when I said, hey, let's start this stream. But let's see. Let's check the battery voltage, and let's see if we can figure out why this board is not getting hot right now. All right, battery voltage is 3.79, so that should be, enough to get this thing to actually boot if it can boot. I'm going to throw it on DC power supply since that's my go-to tool for something that appears to be no power. So DC power supply will tell us if it's actually consuming current or none or high or low or what. All right, so I've connected it to DC power supply, and it's telling me that it's, even before prompt to boot, that it's consuming like 50 or 60 milliamps, which it really shouldn't do. So now I'll prompt it to boot and see what happens. Prompt it to boot. And it's really kind of fluctuating around. I'm going to disconnect that and see that again. Yeah, it's sitting there at like 40. So that's a bit of an odd odd presentation. For it to consume 40, 50, now 65, 67, 68, 68 milliamps before prompt to boot. So what should happen? It should consume 0 voltage because the battery voltage should enter the phone and fill up the battery VCC line. Then it should transfer over and fill up VCC main and then stop because the power management chip hasn't been told to actually turn on and start consuming current to put out all those voltages. All right, so a 60 milliamp short. I'm going to take the screen off because if it's not booting, we don't need that. So let's get rid of the old screen. And let's see what the deal is here. So 60 milliamps. Let's see if I can find any heat. 60 is a little bit low to produce some heat, but maybe we'll find it if we kind of let it hang out. That seems pretty cold. But somewhere is a leak, a 60 milliamp leak. So we're going to see if we're going to sit here and use the face detection method. All right, a bunch more of hellos. It's the coil. Twitch not working. I did not stream to Twitch this time. I took that off. That was just a bit of a variable. It's the coil. Rosendo Hirogo says, I would try a new Q1701. Q1701. What is Q1701? Is that the little transistor that connects battery VCC and VCC main? It's hard to imagine how that guy would create a small short. Unknown error occurred. I don't know what you're talking about. Is it water damage? No, it is not. Twitch stream didn't start, and I can't watch YouTube. It keeps loading forever. Well, I didn't stream to Twitch this time. I decided to go back to just YouTube for this stream because the restreaming app doesn't let me set a description for YouTube that will stay, and I wanted to have that. Hello from Syria. Okay, so it's been kind of hanging out here, running for a while, and I don't see any progress. So let's start this then with the last step that was done, which was replacing Tigress. So let's go ahead and look back at that and kind of consider that maybe that didn't work out. So let's take off this Tigress. Let's see if we can make that clear for you guys. Oh, it's got to be clear for both of us. Got to be clear for me and clear for you. All right, so let's put on some delicious, beautiful Chip Quick Clear. Lovely, luxurious Chip Quick 291 Flux, my favorite. And we'll put a heat sink on the NAND chip. And let's get this Tigress chip off here, and we will just replace it. Just to rule that variable out, since we could have had a bad chip or a bad placement or something like that. Since that was the last thing that was done. The bird's going to heat up for a while in order to release that chip. Yeah, this poor guy, he came in. It seemed to be a classic TriStar presentation, but it wasn't TriStar, so we put a couple TriStars on and it didn't solve. While he's standing there, it was course week, so the students are all busy changing TriStars. And while he was here, 3 or 4 of them were, yay, it works! So they all had success on their TriStar jobs, kind of one by one, while he sat there getting bad news. So that sucked for him. All right, I didn't know it was a short, LOL. I thought it was not charging only. Well, I don't know that it's a short either. How do I know that it's a short? I just plugged it into DC power supply. And there's no reason why you would just kind of come in and change a random chip. That would be just throwing chips at it. All right. All the guys like Amtech better than Chip Quick. In my stream last night with Christy, I talked about why I think that is. And what I think is going on, it's undeniable that the Amtech Flux, which I have Amtech right here, and if you squirt out Amtech, it's got like the snot, like gross appearance with flecks and crap in it. It's undeniable that that looks like human semen. Nobody can look at that and not think that right after you think snot. So my theory is that all the people that work here, with the exception of Mark, prefer the Chipquik. Except for Mark, he prefers the Amtech. And if you're going to go out in the world of board repair, which is 90% guys, they generally, the consensus is that they prefer Amtech. And here's why. My pet theory is that women do not like to put on the board a substance that looks like you just ejaculated all over this board. It's gross. You don't want to take something that you're trying to fix and make pretty and just cum all over its face. It's disgusting. Women don't like to do that. Men get a kick out of it. They like to just come on the board. Take that. Squirt. It kind of gives them that little, Christy described it as little testosterone kick. Maybe there's something to that, I don't know. All right, so we've got Tigress off the board. And I keep getting telemarketer calls on my personal phone, which is super annoying. Go away. Stop. No. Hang up. All right. So while Tigress is off, I will show you what the heat led me to when I looked at this just before I started the stream, that made me think, this might be a good candidate to think about a little bit. So what I found before was a short on that cap. So I wanted to just kind of demonstrate that this cap is short, and therefore anybody else connected to it. So this line has a short to ground. You can hear that beeping on the multimeter. So we know that, and I'm going to show you hopefully how we kind of arrived at that, and then we're going to go from there. But I needed to show you that while Tigress was off the board. But how do you just find that? It's kind of hard to randomly find. So let's put a new Tigress on here, and then we'll go back to see what the sort of overall problem is. So I'm just going to kind of rule out the last thing we did to this, which was to change Tigress. All right, so we'll put a new Tigress on. Here you go, buddy. Your new home. You're going to love it here. I promise that you won't get hot. All right, so let's throw that new Tigress on there, and we'll put some heat. You're right, said Rodrigo. I definitely find it funny that someone's coming on a board. Yeah, see? Guys like that. They like to just kind of get that little, take that, yeah! To squirt the little dick tube of Amtech Flux all over that board, just everywhere. Yeah. Girls don't like that. See, it's just like messy. They like the crystalline, pure, clear Chipquik 291 that doesn't look like snot. Alright, so we're going to wait for this chip to kind of dance around and find his spot. He needs to sit down. It's too high over there on the right. There you go, buddy. Find your spot. I'll give him a tap. Alright, there we go. Okay, so we'll let that cool down for a second. And then we'll go back and see if the behavior is any different just by ruling out the variable of the Tigress that was on there that we put on there the other day. I tend to fall right asleep after using it. Is this the weird part of YouTube? Yes, it is. Yes, it definitely is. Yes, it definitely is. So we're going to let that cool down for a second. Giving new life to a board via Flux. By the way, random thought, is there any way to get stem cells from spunk? Back to stem cells. Is this going to be another stem cell stream? Yikes. I do think it would be kind of fun to talk about various biology and physiology topics while doing things like waiting for boards to cool. But the answer is not really. So if you think about the good kind of stem cells that you want are embryonic stem cells. So that would come from embryos. And embryos require an egg and a tiny little sperm to combine, and that creates the full complement of chromosomes that you need to do anything. So then that cell would start to divide, and you could take one of those cells, and that would be a beautiful human embryonic stem cell that you could use for lots of different amazing things. But if you were to just kind of dissect what kind of cells are actually in a dollop of Amtech semen, the sperm cells that are in there only have half the chromosomes that you need. So, and they're pretty specialized. They're like the opposite of stem cells. They are extremely, extremely specialized. Jessa, should I pay Crest or not? Well, yes, of course you should pay Crest. I mean, you should pay them minus the hotel fee for Venera to go down there and yell at them. I would do that. I would pay them minus your actual expenses legitimate expenses that you incurred making them do the job that you hired them to do, which was to deliver on the product that they promised you they would. So I would print the receipt from that hotel, gas, whatever that cost. I would print that and I would write them a check for whatever they're asking for minus that amount. So we can do that. All right. What else is in here? What's the pitch on the Tigress balls? I'm going to guess 0.2 millimeters, but I don't really know. I'd use, Douglas. Douglas doesn't like Amtech. Way to go, Douglas. All right. Sperm have only half a complement of chromosomes. So no, Zach gets it. He knows. My 2.5-year-old daughter sits here fascinated watching yours and Rossman's videos. I wonder who she takes after to have to watch when she follows me in the lab now. That's pretty funny. I want to come to you to learn more about PCB solution. Lewis feels like trumping them for poor service. Cord blood. Cord blood, again, is, not as good as embryonic stem cells. There's no reason to not. I mean, we're throwing beautiful embryonic stem cells away. Cord blood's okay, but not as good. All right, let's see. Is this a biology class? Yes, it is. It is about, ask all of your physiology and biology questions. I think it's super fun to talk about that. And while you do that, I am going to see what the deal is with this board now. So let's see if we have that exact same, let's use a biology word, the exact same phenotype, the outward expression of genes. Do we have the same phenotype now that we changed the genes? We changed the Tigress from one copy to another. All right, so now I am going to put it, let's go to DC power supply again and see if we have anything different. Let's check it out. Which one is the iPhone 6? iPhone 6. All right, we're just gonna kind of, let's do pop out chat so that I can follow along and see what your biology questions are. We'll do a little hybrid lesson. Board repair and physiology. Sounds great. Okay, so let's see what the result is with a new Tigress, and I see a much smaller leak, 006, so it's not 60 or 70 anymore, 005. So now it's a tiny leak. I'm going to go ahead and go back to that screen and battery and see if this board is going to get hot like it used to when I first started looking at it today. Let's see. Let's see. All right, I got a screen and a battery. All right, connect to USB ammeter, which I don't really have a good way to just leave this so you can see it. Can you still see that? Maybe? Can you? Kind of. Too bad the blue number is, yeah, you can see the blue number. There you go. Look at that, totally professional. There we go, perfect. All right, so now let's plug it in and see what it does. Is it fixed? All right, so now this phone is back to booting, which is good, but it's not drawing any charging current. So now I'm gonna use, Lewis, I don't know if you were here earlier, what's your favorite way, what's your favorite short detection tool? Your choices are A, the FluorCam, B, freeze spray, C, alcohol, or D, your face. Which one are you gonna pick? I'm gonna use my face. So this phone does boot up now, and I can feel it getting warm. So it is getting hot. So I'm gonna use my face. How long have you been working on this board for? I really just started. And it's getting hot. I can feel it getting hot. I'm gonna burn my face off. All right, so it's definitely getting hot. And I can kind of feel around. Let's take the screen off so it boots all the way. Now that we know that it actually will boot with the battery, but it has a charging problem, we're gonna get rid of the screen, put the battery on, and see if we can localize that source of heat. So with just the battery, I'm prompting it to boot. It's still a big 0. I bet he picks alcohol. I bet he picks face. Let's see. All right, so I'm gonna feel around this with my favorite heat detection method called Jessa's face and see where it gets hot. Do I need to shave to detect heat? Not really. Actually, your butt is more susceptible to heat compared to your face, just so you know. I don't think that's true. Here's a little fun physiology thing that you can try. There's this thing called the 2-point touch determination test. And I think that all of us kind of feel like it's hard for us to accept our own limitations from physiology. Like it's hard to believe that if someone was touching you on your back, that you couldn't tell the difference between them touching you with 1 finger and 2. But it's true. You should try this on your roommate or your girlfriend when you get home. If you touch like your lips with 2 very two kind of fine point things like multimeter tips, maybe not the sharp tips. We'll go with the with just these tips. If you touch your face, you can tell 2 points, 1 point, 2 points, even when they're really, really close together, because your face is very sensitive. You have a lot of neurons. But if you do the same test like on your back, it's shocking how far apart these can be, and you can't tell whether it's 1 or 2. So in order to be able to tell 2 points from 1 point, you have to have enough neurons there that are getting that signal, that have the little mechanoreceptors that can receive that sort of pressure input. And if you don't have pressure receptors very close together, then you have no way to get that information, and that's kind of the case. So about using your butt for heat detection, I don't think that you have enough, that you're going to have enough of those little thermal receptors on your butt compared to your face, but what do I know? Maybe I'm completely wrong about that. Let's see if we have a butt physiologist that can chime in. All right, let's see. I know that test from Intro to Psych. Yes, all right. Okay, so we'll put these back on. All right, so now that we know this board is getting hot, and I could feel heat kind of roughly in this section of the board, and if I wanted to, I could probably pretty crisply kind of get down to exactly where that is. But now I'm going to move to an alcohol-based method. Alcohol is a little bit safer than freeze spray. Freeze spray would also work, but freeze spray is a big stress. It's a big shock to the board. So if you have a strong short, something that's really getting hot, and you can tell that from your face. If it's really hot, then putting freeze spray on it, it's going to heat up so much, that's going to be a big stress on the board. So in that case, something like the alcohol method where you're just looking for alcohol to boil might be a better test. So let's do that test. Let's do it. Let's see if we can see some heat. This battery might be getting a little low on charge, but all right, so I'm just going to take the board, flip it up to the side that I want to look at, and foreskin is the best short detecting material. That may be true. The hidden feature of foreskin's short detection, the untapped resource. Stop calling me telemarketers. All right, so Lewis isn't responding to you. Someone pull the stream. That means Lewis is probably said, ooh, Jessa's streaming. I'll stream too. I'll stream opposite of Jessa. Okay, let's go ahead and drop some alcohol on here and see what we can find. So this doesn't give us a really big view, but we'll just try it. All right, so we are going to go ahead and connect our battery first. Flip it over. And we're going to kind of look around here and see what we can see. And let's throw some alcohol in here. So this is just raining down alcohol. Whoa, I see boiling already. Look at that. Can you see that? Look at that. I see smoke. Tigress is on fire. That was kind of fun. Let's do it again. Look at that. Look at that vigorous boiling of alcohol and smoke. Look at that. That is some serious hot shit. All right. Did everybody see that? So this is the strategy that I did just before I started the stream that kind of led me to thinking this was an interesting case. So I stopped working on it and said, hey, let's do a stream on this. So I haven't really gone past here. So we've got a strong short on the board, and we know that it's not under Tigress. That was the first thing I did, was to pull Tigress, and so there was not a short under Tigress. So what do we do now to actually find this short? And that would be probe around randomly in the area and see if you can find a shorted line. Douglas Reno says, I've gotten called by 20 telemarketers so far. Sudden resurgence, I guess. Yeah, we got called by a telemarketer on Christie's bat phone, which is the business phone that no one knows the number to, that we just got just so that Christie's husband could call her. If Kilpatrick wanted to go after Jessa, I suppose they could at least legally make her change business name since she's using a trademark. Oh yeah, I mean, iPad Rehab is the dumbest name ever. I mean, that's dumb. I can't stand fixing iPads. We constantly get called for, do you fix anything except for iPads? Yeah, we try to fix everything except for iPads. iPad repair sucks. Nobody likes fixing iPads. And then the iPad Rehab was we're calling up old ladies to say you can come in to pick up your device, and so it will be, hi, this is Sunday from iPad Rehab, and we want to talk to you about your device. Rehab? Who's in rehab? What rehab is calling me? Oh my God, who's in rehab? So yeah, that was the dumbest name ever. But I haven't changed it because I kind of feel like it will be like a badge of professional accomplishment if I ever did actually get the some kind of a hey knock it off letter from Apple, in which case I would just say fine, you win, and then change. But all right, let's go here and see if we can find the short. It's going to be pretty easy since we already know where it is. All right, so from here you can just kind of probe around. Nope. Nope. Yes. So these are capacitors. They should not have a path to ground on both sides. All right, so we have a short on whatever that guy is. So now we've got something to follow. We've got a lead. Hackers found your number. If you have a short close to Tigress but not on Tigress, shouldn't it stay cool and the component with the short get hot? Well, let's see what you think about that. So there's no rule that says that the only place, oh, we're streaming, by the way, that's okay. There's all the intake was in a giant bucket in the back. Did you see it? Okay. You can chat. It's just work. Okay, just be yourself. Did you see Christy's stream last night? She fixed something awesome and amazing. Yes. Yeah. So she did great. Yeah, she faced her fear of live stream. Okay. So here's the thing with all of these heat-based short detection methods. They are not superior to finding it with your multimeter. They just can speed you up. So really you should try first to use your multimeter to find it. Because if you have a short, for example, under anywhere on VCC main, for example, anywhere under VCC main, and you use a heat-based detection method, the same component will light up as I'm getting hot first. That's completely unrelated. And that guy, I'll show you. Since we're gonna go look on, let's go ahead and look at ZXW, I guess. So we'll take you guys over here to ZXW land. So this is iPhone 6. And if I were to, this is just an example, if I were to click on VCC main, now anything on here is on VCC main. That could be the reason why VCC main is short. But if I apply something like freeze spray or a fluorocam or alcohol or any heat-based short detection method, the thing that's going to get hot is this guy, so Q1403. Q1403 is going to get hot. Now why is that? Let's first think, if there's a short on VCC main, is there any way that Q1403 itself could be the source of the short? Let's find out. Who are you, Q1403? Q1403. Let's see. Tell us about yourself. Tell us about yourself, Q. All right, so Q1403, it looks like it connects battery VCC. There's 3 little balls on that. To VCC main. All right. Now we know that a short to ground means a wire to ground. Something has become a wire to ground. So as you look at that, is there any way that Q1403 itself could turn into a wire to ground and allow VCC main to have a path to ground? Well, let's see. This says no stuff, so that means this is not present. It's not placed on the board, so that's not a path to ground. And this just goes back into Tigress over here, so that's not really a path to ground. So Q1403 really can't fail in a way that causes it to have a path to ground. So then the question is, why does Q1403 heat up? So why do you think that is? Why does Q1403 heat up when it really can't possibly be the reason why you have a short to ground on VCC main? So think about that for a second, and I'll see if you have a good answer in chat while I look up the caps that are actually short on our board. So who are those guys? So we can start with ZXW, and these guys are short. All right, so here we are, C1409, C1407, and these 2 little dudes here. All right, so who are you? C1409, tell us about yourself. What do you like to do all day, C1409? Tell us. All right, C1409 looks like it is on a line that's called PMID cap. All right, what else is on that line? PMID cap, there's 3 caps on it and a no stuff, meaning he's not going to be there. These guys go into some spot in U1403 Tigress. That is PMID, whatever that is. Let's see if it goes anywhere else. Let's see if it goes anywhere else. So we're going to do copy and paste. All right, this is just information saying expect a max of 5 volts on PMID cap. And that's it. So that's it. It's a tiny little dangling appendix off of Tigress that only has 3 caps on it and nothing else. That's all it is. That's all that it does. That's the only place that it goes. All right, so we'll kind of see if, I want to see if you guys answered me about the Q1403 stuff. Let's see if you guys came up with a good answer for that. Let's see. I'm going to scroll back and see what I missed in here for a second. Biology class, I saw that. Did Lewis get his new toy today? I don't know what that is. Incoming call from Lewis Rossman. That sounds unlikely to be true. Really? That sounds like a butt dial, which is 90% of those. Missed call from Lewis. That sounds like a troll. All right. I have an iPhone 4. What's your PhD on molecular genetics of pancreatic cancer? All right. Other questions. Oh, multimeter. Other questions. Croatia. There you go. I know there is, but she bought some once. I don't know what you're talking about. My iPhone 5 is not charging. Lewis loves the FLIR cam. I don't think he does. Your lips are super sensitive to heat and cold. Yes, they are. Use your tongue. That's not a good idea. That's not a good idea. Let's see. Let's scroll down. The 2-point touch on foreskin is incredible. Such a highly innervated tissue. Who knew? All right. Let's see. Thanks for the butt clarification, Jess. I used that technique for ages, but at last I will no longer be embarrassed when my clients walk in. Okay, good. Somebody learned something today. All right. Telemarketers getting sued. Watching this live. Hackers found your number. Question about short. Just joined. Was it the coil? No. No, it's not the coil. I don't have my shirt on today. Not always. If Tigress has to do the current limiting, it'll dissipate the heat and not necessarily the shorted component. Depends on the current flowing through it. That's a good answer. I like that. All right, where's the Twitch stream? I didn't know you guys love Twitch so much. I didn't stream on Twitch for this stream just because I wanted to have a description on YouTube, and I can't have a description on YouTube until after the fact, until I figure out this restreaming stuff. And I can't ask Lewis to help me anymore because I walked in this morning and my entire, I'll show you what my desktop looks like after. This is what it looked like when I walked in today. Let me minimize all this screen. This is my desktop. This is what it looked like when I got to work today. I did not do that. I did not do that. So I can't ask for Y chromosome help anymore on setting up computer stuff. What are you gonna do? All right. Reballing CPU. All right, here we go. Q1403 is just a MOSFET transistor that works as a gate between VBAT and VCC main. Yes, it is, but why does it get hot? That's the question. Why does it get hot? And taking too much voltage. That's not it. Nope. The output short. Nope. There's no path to ground. When you say short to ground. So that way it helps you to think about this. Power not going anywhere. Not the word. The word isn't power that you're looking for. All the current flows through the 1403 chip. It does, but it would also flow, throughout the whole board until it goes down the hole, which is wherever the short to ground actually is. That's where all the current is going through. Current is everywhere. It heats up because having more current through the one he is designed for, that's why he's overheating. No, they're all like every single cap, every single component, every single chip, everything on the whole tree. Let's say the actual short to ground is here. Everybody is having inrush of current because of that short to ground. All right, let's see. Can you guys get it? Short on VCC main could cause it to heat up due to excessive current. The chip is feeding the short. Nope. Come on, guys. Figure this out. Where is this? Q1403 gets hot when there's a short to ground because all the power, regardless of battery or main, goes through it. That's a good guess. But I want you to think it has no path to ground. That's the key. It has no feet on ground. It is not touching ground. So why does it get hot? When I have heat on Q1403, I bypass it to find where's the heat. Okay, but let's answer the question. All right, cap is shorting Q1403 to ground. Nope, the short could be C5202, way at the end of the phone. Anything on VCC main. It's all together. You know, if you've got a hole in the aorta has a hole in it, and you're going to have low blood pressure in the entire aorta because of the hole. If you have a short to ground, you have a path to ground, so you're going to have current running everywhere throughout the line because somewhere you got a path to ground. So why does it get hot there? All right, let's see. I think everybody's giving up. Is there a short on Q1403? It's impossible to have a short on Q1403, right? Tell me why. Let's think. This is use your brain video. Nobody's getting that? Really? Seriously? Can we see the schematic again? Ah, thank you. Freak-a-fari. Freak-a-fari for the win. It cannot dissipate the heat to ground. Yes, somebody is using their brain. Let's look at the schematic again. That's a good idea. It cannot dissipate the heat to ground. Yes, so let's go back over to our buddy Q1403 and answer the question. So if there is a short somewhere over the rainbow on VCC main, way up high, somewhere there's a short on VCC main, there's a path to ground. So you have current going through VCC main and going to ground anywhere on this line. So why does this guy get hot? Because unlike this guy, unlike that guy, unlike everybody, he does not have a foot on ground. He does not have a foot on ground. So he has no ground plane, no heat sink, nothing to do with the heat. So he heats up because he doesn't have the runway of ground plane to dissipate that heat into. And everybody does but him. So that poor fucker is going to get blazing hot, even though he can't possibly be the reason why there's a short to ground. All right, and I see people, I make a point of that because I see people all the time just kind of blindly accept that whatever gets hot is a short. That's not true. Sometimes it's true, but it's not a universal rule. So you have to think, what you can also have something that has a lessened ability to diffuse the heat into ground. That thing's going to get hot even though the short's at a distance. So it's just a tool. It's got to have a ton of false positives and false negatives. It's just a tool. Sometimes it can give you a clue, and a lot of times it's useless. So heat is never your first go-to way of finding shorts, in my opinion. All right, so now let's go to what we're really trying to figure out here, which is what's the deal with where we actually have a short. So if you're just kind of tuning in now, we found that in our iPhone that does boot, but it does not charge. It pulls 0 charging current. Tristar has been changed. Tigress has been changed. Tigress is getting hot. And using the multimeter, we found a short on this line, PMID cap. All right, now here is why I wanted to stream this, because I wanted to kind of to show you guys how it is that you can approach this. I want to encourage you to just accept that you don't really need to know anything more than the ability to think and ask questions and to kind of weigh things and kind of make a hypothesis. So board repair is more about being a scientist than it is about being an electrical engineer. I mean, if you're an electrical engineer, that's great. You have a lot of foundational knowledge that you can apply, but that's not required in order to just think and ask questions like a scientist. So how are we going to figure out what the hell is PMID? What does it do? What do we do here? And we could just kind of get, I'm saying this to help you guys solve lots of problems where you kind of get stuck on a line and you get to the end of Please Bro Solutions. Please Bro Solutions says, iPhone 6 not charging, change TriStar, bro. That didn't work, change Tigress. That didn't work, change Q1403 or whatever, just kind of random shit. So what do you do from here? So what do you guys do from here? I'll show you what I would do, and this is what I did. I am going to open up my good buddy Internet Explorer, and I'm going to open up I'll open up a new tab over here. So let's kind of have you guys come along this journey, and I'm going to say, hey Internet, what is PMID cap? What's that? Anybody? Have you ever heard of PMID cap? Huh? We got a lot of cool genetics articles. Awesome. No, I don't think that's going to have anything to do with this. So this is all finding PubMed ID. These are going to be from the NCBI, which is where all the wonderful research in the world goes to live. So that's why we're picking up this PubMed ID. So we need to change this. Let's say, what about the concept of PMID and charging, or charger, something like that. And this is where I went. Let's click on this. Looks like I already did. PMID pin. Okay, maybe this guy maybe we can learn something here. So we are going to give ourselves permission to not be designers and not be electrical engineers and just say, what the hell is this? This guy has a question about the PMID pin. Please see the below data sheet. There's a PMID pin on the chip. The data sheet says it's a power input pin, but I don't know what this pin is for. And we can read some answers. The table on page 4, you idiot, says that the pin is used to bypass, decouple some of the input circuitry and thus requires a capacitor to power ground for that purpose. And this guy doesn't know what that means. But I wonder, what kind of circuitry is connected to PMID by a switching charger application? And this guy says, just a capacitor to ground, you retard. And then this guy says, then they go on and kind of debate this a little bit. But what I think is interesting is this doesn't sound too terribly far off from our application. This guy's talking about a switching charger that has a PMID pin. Well, let's click on his data sheet. That sounds cool. Let's see what we can learn here. So this is not Tigress. This is a completely unrelated thing. We're just kind of see what we can learn here. All right, this is a USB compliant single line lithium ion switching charger. Okay, that sounds reasonably close. Let's see what this is. All right, so this says, maybe we can learn a little bit about how this stuff generally works. This is some family of chips, combines a highly integrated switch mode charger to minimize single cell lithium ion charging time from a USB power source. That sounds like us. And a boost regulator to power a USB peripheral from the battery. That sounds like us as well. The charging parameters and operating modes are programmable through an I2C. I don't know. I feel a little guilty not saying I squared C because that's actually says squared, but I just can't do it. Interface that operates up to whatever charger, boost regulator, switch at whatever. Ensure USB compliance, minimize charging time that, here we go. The input current is limited to the value set through the I2C host. What does that mean? I mean, somewhere in Tigress, there's probably going to be some data lines that is going to set a limit on the input current. So that means those would be important for charging. All right, then it talks about when it knows to turn off, safety. The chip restarts the charge cycle when the battery falls below an internal threshold, so it kind of comes on by itself. And what happens if you disconnect? All right, here's something that I think is really important. Charge current is reduced when the die temperature reaches 120 degrees Celsius. And then it's going to go on, and we can kind of see here's this chip has PMID. So what do we kind of gather from all that? Let's try to kind of use the skill here, and this is what I think is most important, is you have to kind of get an impression. Like, you got to ignore a lot of stuff, and there's words you don't understand, but you kind of have to get a nutshell. You know, what useful information was in that blurb? What can we apply here? What is PMID? What does it do? If you don't understand electrical engineering, what can you get out of that? And I want to kind of see what you guys think, and then I'll tell you what I got out of that. And how does it sort of relate or apply to what we're talking about? So let's see. Let's read some chat and see what you guys got out of that. All right, so I have to head back to where we left off. All right, I saw that. All right, are you heading to New Orleans later this year for the conference? Nope, because it is on Halloween night, and that is a kid holiday, so not happening. After water damage and short on VCC main, what could be the problem? Oh, anything. All right, ZXW dongle. Is there a short on Q1403? Not possible. All right, material sourcing. I did one early today, and it was the coil. That's a charging coil is short to ground. That's not possible. That is not possible. All right, where is everyone? It gets hot because it's not sinking all of it into the board layers. That's pretty close. All right, more surface area on the chip. Why do we keep having all this coil chat? That sounds like chat cancer. There we go, Freakafari with the cannot dissipate heat to ground. Yes. The only other way is Tigress only turns it partially on, thus having a potential difference across it, but not fully off. That would cause resistance, less heat. Maybe, that's not unreasonable. After water damage and short on VCC main, what else could be the problem? Can't find other short. You got a short somewhere. You got to find it. I suggest using your face. All right, let's see. All right. The winner. It's not touching ground, but if VCC main is shorted to ground, all the voltage from the battery goes to ground. It's just a bridge, kind of. All right. Whatever gets hot needs to be replaced. No? No, that's not true. All right, there really isn't any other component that has no path to ground. And if there is another one, wouldn't that also be getting hot? Yes, I think so. But a capacitor shorted to ground gets hot and they only have one pad to ground. Do an experiment, you know, put a wire across the most common VCC main failure, C5202, make a short to ground, power on the board, what gets hot? Q1403, how is that possible? You know, sometimes a capacitor will get hot when it's a wire to ground, but it's just a red herring. All right, let's see. Let's get past all this. Battery boost mode output voltage connected to the drain of the reverse blocking MOSFET and drain of HSFET. All right, squared. Somebody's bothered that I say I2C. I can't help it. Oh, good. Jim Bush says in Flemish we also say I2C. That's right. All right. PMID can be to boost the battery when below 3 volts. That's not really what it said. I like the guess of power management identification. That's would have been my guess. Will the phone always overheat on a short? It depends on what line is short. So the answer is no. All right, here we go. The heat generated from the short might trigger that to stop the charging for phone for safety. Is that consistent with what we just read about how the in theory similar, charging chip works? And the answer is yes, because it said charging, there's a safety net that if the die reaches 120 degrees Celsius, charging will stop. We saw this vigorously boiling. Water boils at 100 degrees Celsius, so we can easily imagine that this phone does get above that. All right, put some voltage on the board and the shorted component will heat up. No, we don't need to do that. All right. It could have a short to ground if some of the heat dissipation layers, which Q1403 is connected to, is somewhere shorted to ground. Q1403 is not connected to heat dissipation layers. That's the point. It's not. It's not. All right. Jessa, I will take the class if you the one teaching. Well, yes, I'm always the one teaching. Enough of the it's the coil shit, that's boring now. Yes, is that Finch? All right, so PMID won't allow to charge due to heat. So that's one idea. PMID won't allow it to charge due to heat. That's very consistent with our problem. All right, so here's the deal. What did we get from that? What did we learn? And the answer is we learned that one thing, that there is a safety mechanism. At least this is not the same chip. This is a similar chip, and we're just going to apply and guess that maybe it's the same. That there's a mechanism where the Tigress chip will shut down if it's too hot, and it's going to be too hot if you have a path to ground on what this PMID pin, which appears to receive the 5 volts from the charger. And then number 2, what is the job of PMID? And it kind of seems from that entire thing that we read that PMID is kind of allows a sort of dump to ground of allowing the Tigress chip and the logic communication within Tigress to be the current limiting factor in charging. So that kind of is really consistent with how could PMID caps become damaged. So if you had some sort of charger insult, which normally takes out tristar, and maybe it did in this case, but we've already changed tristar, so we won't know. And maybe it took out Tigress function. We don't know because we've already changed Tigress. But maybe it also damaged, it just exceeded the voltage capacity or the rating of these nearby caps, perhaps, and turned one of them into a wire. So I just kind of wanted to, most IC do have a thermal cutoff, right? So I like that idea. We don't know if that's true or not, and we could get out a thermocouple and kind of see what the temperature is, but we would know with reasonable certainty that if the temperature on that IC exceeded some threshold, then it wouldn't charge. So where are we going with this? I think now it's time to say, okay, we learned something. So now we're gonna kind of know PMID a little bit. And the next time we see we're troubleshooting a charging problem, or the next time we see PMID on some other chip with a charging function, now we've added one little tick mark to the sum of our experience base that we can then apply and just sort of know, that was bad in this one phone, and know a little bit about how it can cause problems and how it might not work. So I think that's good for that. So let's get back and see if we can actually solve the problem, which hopefully will be straightforward, because how does something get short to ground? We know, let's look back at the schematic. We know that, I lost my schematic. We know that there's a short on this PMID cap line. So let's go to screen. We know that there's a short on PMID cap line. And we know also from what I did at the very beginning that it's not under Tigress. So while I had Tigress off, I showed you guys that there was no short there. So it's not under here, and this guy's gone. How do we have a short to ground on this line? And the answer is it's really going to be cap 1, 2, or 3. So that's kind of where we're going with this. All right, so let's go back here. All right, so I am going to put this back here. All right, I'm just wondering, do you already know what the fault is, or are you like the rest of it trying to figure out what it is? Here's the deal with me and this phone. The history of this phone in my possession is this. Local customer called, phone's not charging. Like an idiot, we said, sure, bring it on and by while we're doing TriStar Day at the course last week. So the guy brings it in, and apparently he drove an hour. So he was going to wait for us to do it on the spot, because the classic fault would be TriStar failure. So Mark sat here and put a TriStar on it while all the students were doing TriStar. And the guy is standing there, and then the students were like, I'm done, yay, it works, it charges. And the next student, I'm done, yay, it works, it charges. And Mark doesn't charge. So Mark does another TriStar, and it doesn't charge. So then Mark does Tigress, because that would be the second sort of signature common fault, and it still doesn't charge. And so at that point, we couldn't really take time to put into, what's up with this phone? This phone's a little weird. So we told the guy, this isn't something that we can fix while you stand here and wait. So he goes back home, and we go return to teaching the course. And then it kind of lost its usefulness as an example. So now I'm back to it today. So I just came in, whatever, the 5 minutes before the stream started, and I was like, what's up with this phone? So what I did was I replaced Tigress, which is the last thing that Mark had done. And then I noticed that the phone was getting hot. So that points to a short somewhere. So then I used my face, and I did feel heat, and it was very strong. So that told me I could use the alcohol method to see if I could locate where is it getting hot. And it was getting hot around Tigress. But since I knew it wasn't Tigress, I used my multimeter to probe around, and that's how I found the short on the PMID cap. And that's when I stopped, and I said, this is interesting. I like this idea of kind of looking up what is PMID cap and what does this line do. And I wanted to I thought that would be kind of an instructive video. So I said, hey, let's stream the rest of this repair. So this phone is not fixed. I don't know that it can be fixed, but now we're all on the same page. I don't know what happens next. All right, so what do we do, guys? We know that we have a short on a line that has three caps on it. So let's see what we can learn out of this. I'm gonna kind of go back to this, and all right, I wanted to check and see what does this video look like. Checking out all of my YouTube settings, let's see, I want to kind of pull this up and see what this looks like live. And what I really want to do is check my new website, which apparently is going to tell me when things are live. So I want to check that while you guys are telling me what we should do next. So I'm going to leave it up to you guys to fix this board. All right. So, meanwhile, I'm checking to see my new website, whether or not my little YouTube Live plugin works. Ah, it sees it. That's pretty cool. I kind of like that. So that's working. Yay. All right, so let's go back to that. All right, this Streamlabs thing, I don't know if that works or not. Okay, so let's see. We've got you guys answering. I can become a second pinata just to learn. All right, can you explain the difference between tristar and Tigress briefly? You got no, you got to go look that up, and then you tell me. Whip the caps off and test the line. Sounds good. Will Q1403 will work? Probably. Replace the shorted cap. Okay, which one is it? You tell me. Check the 3 caps for a short to ground. There's a short to ground. Take off all the caps one by one and test each time in between. That sounds good. I like that plan. So Jim, you pick for me which one it's going to be, and don't fuck it up, because you need to pick the right one, because I don't want you to waste my time. All right, so let's put it back under the microscope, and let's see where the caps are. So here's 2 of them, 1, 2, and I think that the tiny one is number 3, but let's find out. So it could be number 1. So is it him? Let's call him A, or B, and then the other one might be this little guy. Yep, or C, the little guy. All right, Jim, tell me, A, B, or C? A, B, or the little guy C? Tell me which one is the bad one. All right, let's see. How the heck do you find a short when the phone does not overheat? Because you use your brain, not heat. Caps lottery. Alcohol first on the caps. Nope, we're not. I mean, if you have to realize that every time you do something like boot up a board and put alcohol on it, or just have a board underpowered where you know there's a shorted line, that's not good. If you don't have to do that, then you shouldn't. So you want to kind of be conservative when you can. If you can find something with a multimeter, use the multimeter. If you can't, then use some kind of short detection thing. Ah, stop that, it's so mean. All right, so we are getting lots of votes in. All right. All right, so let's see. Use your nanometer to check which one has the lowest resistance. That one's shorted. If we had the ability to do that, that would be a great idea, but we don't have that kind of level of resolution. All right, we got cap 2, one of the higher capacity ones. Zoom, please. Left one, I'd say B. All right, let's see. So it's all Jim's fault. All right. Oh, Jim wants me to zoom. All right, Jim. If it's going to help you get it right, I will zoom. I will zoom for you. All right. There you go. That's all I got for you. Here. A, B, or C? So there you go. Is it A, B, or C? All right, Jim, pick the winner. Don't fuck this up. A, B, or C? The one that beeps the most. Nope. All right, we got to vote for B, C, B, 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 B. Another vote for C. Don't see anything on the iPad Rehab's website showing live streaming. No, it's my new website, which is not live yet. All right, some coloration on the A cap. Another vote for C. Definitely not C because small caps are less likely to short. Bunch of C's. A is easiest to remove, so that'd be my pick. Well, I've got A 16 volt, B 16 volt, and C 25 volt. Check C. Well, wouldn't you check the ones that are more likely to be destroyed by overvoltage, like A or B? From the bad video here, wonderful. All right, Jim. Is that a splat on the A? I don't know. Your eyes are just as good as mine, probably better. I'm going to take that as you guessing A. All right, so I'm going to say Jim's guess is A because he thinks he sees a splat on that. All right, so we're going to put him down for A, and we're going to blame him if he's wrong. We're gonna make him Jim. How about this? If you're wrong, you need to donate $1. If you're wrong, I don't think you're wrong. Actually, I would have picked A. So I'm gonna make that be a punishment. All right, are you ready? Okay, let's do it. Let's go ahead and take off A. All right, so we're gonna get a little bit more clearance. So what's a good method to take off these guys? All right, let's see. Let's take off. Ugh, look disgusting. Amtech, gross. All right, so these are going to be a little bit hard on the mini hot tweezers just because it's a big cap with a big ground pane, so I'm going to increase the thermal linkage with a little bit of extra solder on my tips. And we are going to take off A. All right, come on, A. Come on off. All right, and now we find out if Jim is right. Okay, so here we go. We're going to put a probe on ground. This is the moment of truth, and we're going to listen. We're going to touch the two probes together, hear the beep. One side, and still short. God damn it, Jim. That's all right, Jim. You gotta donate $1 on Streamlabs, which is actually something I need to test to see whether or not that works. You don't have to, but if you are a good sport, you will let me know if my Streamlabs is working. All right, and the next time I see you, I will I'll give you $2 for donating $1 on there to let me know if my Streamlabs link is working. All right, now we have no choice. Let's go for B. So we're going to go for B. I saw Jessa at Lewis's removing caps with an X-Acto knife. Yeah, man, that's the way to go. That's the 5 o'clock method for data recovery. For this application, these guys need to go back. All right, so let's go ahead and take off B. All right, come on, B. Come on, B. All right, we'll put B over here. Okay. Now, was it B? Oh, you guys missed that. Sorry. Damn it, Jim. All right, so Rosendo is confident that it is B. Let's find out. I'd be surprised if it was C, so I think we're going to be good to go. But let's find out. Oh, it's still short. I'll tell you what's going to suck if it is in the board. All right, so it's not B either. That's going to suck if it's not C. All right, come on, little C. All right. We're down to our last chance. What? Now that surprises me. That surprises me. All right, now we have to clean it off and look for some kind of a mechanical short to ground. So I'm pretty sure that was the only things that were on that line. So let's go back and look at the schematic and just sort of make sure that we aren't missing something somewhere. But I would have expected that to be the case here. So let's find out. Let's see. So where do we go from here? We're going to confirm on the schematic that we're not missing a piece of the line somewhere else or some cap, those were the wrong caps or something like that. And then we're going to look for a mechanical short on the board, like some kind of ground plane that is attaching to a pad that it shouldn't be. So let's look for that. Yay! I bet that SuperCal Second donated $1 for Jim for wrong cap guess. That's hilarious. I like that. All right, so let's go to the schematic. All right, now let's just make sure. So we see our 3 choices here, A, B, and C. And I'm pretty sure that these are the only things, at least according to the schematic, that are on these lines. So let's just make sure that this matches up at ZXW with our area. So this was A, this was B, this was C, and then it goes under the chip. And we didn't have a short when the chip was on there, when the chip was off. All right, let's look. Is there any place else that ZXW at least thinks it goes? It really doesn't. It really doesn't. It really doesn't. All right, so then let's go back. Now, the next step for us is to take a really hard visual look for some kind of a mechanical short that we might have missed. And then next after that would be to take off the chip and really have nothing on the line and see if we can clear the short. Because if not, the short is internal to the board, and that's always gonna suck. That makes things complicated. That's gonna suck if that's the case. All right, so let's get some. Let's kind of just clear this out. So let's get a nice close-up on this. And see what else is going on here. So it looks like this little resistor here is touching a cap that it's not supposed to. We can move him out of the way. Yeah, but it looks like you can pretty well read the board and see that the PMID line is everybody that is in here. So this is all that PMID trace. And it's a little odd that I see some discoloration in the board there. That's a little bit rare. Yeah, so that line, this is the ground, and this is the line, and we're looking to see is there any way that there could be just a mechanical connection to ground? I don't really see it. All right, let's move that resistor guy while we're in the area. So let's just move him over just to eliminate variables. All right, come on, dude. You look a little fucked up. All right. Bend the top of it off. All right, so now we just are gonna make sure this is still short, which it is. All right, so now the only option we have is to take off Tigress again. So we'll take off Tigress again, even though we saw in the beginning of the stream that we had that short on that line without Tigress. So that is the only thing left on the line. So we're going to take that off, and then we have to conclude that the short is actually within the board there in that area. So then we'll have to kind of that's when we'll have to get creative if we want to solve. But let's go ahead and make sure that we didn't somehow also cause a short. Maybe Tigress got damaged and that line is now short within Tigress because we did put power through it, so who knows on that. So let's go ahead and take off Tigress, and that will kind of complete the elimination of variables on this short. All right, so let's do that. Kind of interested to go back and ask if any of these caps were actually wires or not. All right, so Tigress is off. Let's just tidy up those pads to make sure we don't have any kind of weird bridging. That doesn't look like we do, but we'll just rule that out. And I will see what you guys think about that. All right, could Tigress have been shorted by the amount of heat it created? I would remove Tigress before probing any more too. Yes, didn't it kill Tigress? Well, we don't have any idea. All right, put a wire on the PMID cap and a wire on ground and send a current limited voltage supply on it. That's a bad idea. Who can tell me why that's a bad idea? Why is that a bad idea? Why is that going to tell me nothing? Why would that tell me nothing? Why would putting voltage on the PMID cap tell me nothing? You guys are supposed to be learning from Lewis, not just listening to rants. You got to think. All right, there's our there's a little PMID pad right there. So it is possible that that we could have also created a new short within Tigress by turning it on. That's our only last hope, that we created a new short within Tigress by turning it on in this state. But let's go ahead and ask these caps if they're wires while we're at it. See if any of them were actually shorted. So let's see. Could two separate circuits become shorted together? Well, the word short generally means a inappropriate path to ground, but yes. And so when we have two circuits, we call them bridged. All right, so this guy was not a wire. That guy's not a wire. So A has been exonerated. Let's check. I lost my plunger. All right, let's check B. Let's just see. Were you short in addition or not? Or were you fine? Let's ask him. There's a cap to our left touching shield. I don't know what you're talking about. Ha! So this guy, this was B. So you guys that voted B, he is a wire. He is a wire. So he was short. So now our hope is that the problem was that B was shorted, so therefore the line was shorted, and that when we put current through Tigress as our test, that Tigress internally, because of that same problem, that line was short. It had a hole through that cap that was a wire, that when we put current and tried to turn this sucker on, that Tigress itself developed kind of burned up that line within the chip, because the chip also has a path to ground. So then we'll cross our fingers that taking off Tigress has now relieved the short. Otherwise, the short is internal to the board. So let's find out. Let's find out. Okay. What is this going? Wait, what the fuck is the cap doing on the ground of the shield? I put it there. I removed it. It's my storage place. It's just hanging out, doing nothing. We already know there's a short. iPad rehab, if the coil is cracked, it's not the coil. No, that's right. The coils can be cracked. They don't give a shit. Lewis does it without Tigress on it. If there's a short in the board, it should heat up. Best case burnout. That is what I'm questioning you on. Best case burnout. Let's ask a question. If I took a piece of metal, a wire, and I soldered one end to a battery, and I soldered the other end to the other side of the battery, what would happen? Would it get hot? Yes. Would the piece of metal burn out? No, that's the point. If you have nothing on the line, it's just wires. You can send all the voltage you want through wires. They're wires. There's nothing to burn out. There's no point to it. You can't learn anything. We already know where the short is. PMID line is short. And if we have a line with nothing on it that we apply a voltage to, there's nothing to burn. It's just a wire. That's why that doesn't make sense. All right, just drilling the tristar would have fixed it. Lewis would look at the board and it would be great again. All right, Rosenda says, I knew it! It was B! That's right. All right, is the short gone? We don't know. All right, let's find out. Okay, so now, so here we are, just to review, we found that the original problem was the whatever cap BC 1407 on the PMID line was a wire. That thing had actually failed. It had become shorted to ground. So that was the original problem. But even when removing it, we didn't relieve the short. So why is that? When we knew from the beginning that the short was not present if Tigress was not there. And so now we're going to go see if taking Tigress off again has finally relieved the short. So let's find out. So we are going to test. All right, short. Are you still there? Yes or no? Are you still there? Yes or no? Ground side and quiet. Yay! Ding dong, the short is gone. All right, so we found the, so we got it. So the original problem was B, but when, and this is a good lesson on, why don't you just put voltage through it? Why don't you just put heat through it? We turned the board on and we sent voltage through a line that was shorted, and what happened? It killed a chip. Killed a chip that wasn't dead before. Now we killed it just now. All right, so now let's rebuild. All right, so let's, what should we do for rebuild? Let's put on our Tigress first. Let's see what we can save. I don't want my little dudes to float away. So I'm going to go to my graveyard, which is where I put these things for safekeeping. So there really shouldn't be anything wrong with C. So here's our buddy C. Here you go, C. All right, you can stay there. And we'll get our buddy A. A, falsely accused A. Poor little A. All right, and those guys will really snap into place nicely when we put our new Tigress on there. So let's just make sure that we don't have our short. Oh, damn, we do. All right, fuck you, A. Fuck you, A. Thought that I measured you and that you weren't short. All right, fuck you, C. Poor little baby C. All right, did we actually get rid of our short? Let's confirm that and make sure they just didn't not get a reading because of flux. Yeah, short's definitely gone. All right, let's try A again. Don't screw up the orientation. That's pretty funny. Good one. All right, so it's not A. So let's ask C. If C, are you a wire, C? Are you, a little fucker? Are you a little fucking wire? Or not? Oh, he says he's not. Okay, I'll believe you. All right, then let's try to get you in your spot without fucking up. How about that? Let's get you in your spot without bridging anything. Rotate. Come on, mofo. There you go, buddy. 10-4. All right, now how are we doing? It's sad how excited I get on these cliffhangers when testing these theories. Yes, then you are a person that likes board repair. All right, all is well, and it was just fucking B. B is a fucking wire. B, you bitch. What I think would be cool would be to make like a little necklaces of shorted caps that I found that are now wires, and like use it to kind of like make some battery powered like LED cap necklace. I think that'd be pretty cool. All right, so we're going to eject B from the board because it has failed us. And now we're gonna, I think we should probably, just because this is charging and charging tends to be really prissy, I think we're gonna dig up a donor B. All right, so let's grab one. All right, from donor board. Let's grab a nice little B. Come here, B. We need you, B, to make this board great again. It's going to take a little bit of heat. So here's the thing, like, how do I know I can take this cap and that it's good? From experience, you know, if you know how a board failed, like I can see on this board that it failed due to water damage, which is not a charging over voltage situation. Thanks. Lay back down. All right, so we're gonna grab that dude and we're gonna bring him over and put him in his new home. I gotta put this hot air away first. So early on, I would, measure or worry about stuff like that. But the reality is that this board is probably okay without that cap, and the only reason I'm putting it back is just because charging itself tends to be a little bit prissier than other faults, and because the likelihood that this kid is going to kind of continue using that same charger. All right, so we're just going to kind of get him lightly tacked into place. And then we're going to count on the hot air from the chip to put him where he's permanently seated. All right, let's just check and make sure we didn't grow back our short again. We did not, so now we are good to go on a new Tigress. We're good to go on a new Tigress, and then we'll test and see whether or not we need to do a tristar, just because tristar tends to be really prissy. I better have another Tigress, I'll tell you that. Is this a Tigress strip? Are you a bunch of tigri? Let's find out. Let's find out. Pretty sure you are a strip of tigri. All right, gotta make sure you get your dot in the right spot. And I'm going to turn the board so the heat goes away. I'm going to give myself a heat sink on the sensitive NAND chip. All right. Don't be an asshole. That's right. Remember when I said it's B? Oh, we can scroll. We'll find out. We'll find out. We'll find out who could predict it was B. Chris T says, I watch Lewis and Jess to relax. My taste is weird, but healthy. Yes, it's kind of like these little, it's like choose your own adventure books to some degree, I think. All right, so let's make sure that we've got our dot in the right spot, and we'll go ahead and throw some heat on that and get that chip on there. Soldering SMD components is hell. No, it's not. It's totally fine. It's a relaxing Monday afternoon. Nice relaxing day at work. Actually, I just stopped in here. I only stopped in here to pick up my license, which is pretty funny. I had the course week all week last week, and we have back-to-back course weeks starting on Monday. So I was planning to kind of keep it light. I had the business phone, so that was fun. I got to talk to customers, which I rarely get to do, so that was kind of fun. So I came in here to pick up my license that I'd left here. And then I was like, well, I should help out this local guy. And this poor old lady, she had to come pick up her iPad, which was, I think old ladies are super cute. Let's just nudge this. All right, he's fine. She was so cute because she was all confused because of her ticket had said, needs a white screen. She had an iPad mini. We're going to let this cool down and then we'll test it. She had this iPad mini, just straight up crack digitizer job, and it was a white screened iPad mini. So the ticket said, needs white screen. And she was like, well, I never use the white screen. I just use the black screen. Like, I don't understand. Is there something wrong with the white screen? Because I just want the black screen to work. That's all I ever use. And so I had to do this whole lesson on parts biology. Like, well, here's a black screen. Here's a white screen. Super cute. Super nice old lady. So she came in and got her iPad today. Okay, do you often get secondary issues due to heat on fixed boards, such as proximity issues on like a Touch IC repair? On something like this, no. But on something like Touch IC, if you're getting that, then you probably want to change your angle to something else. I used to get them when I first started doing Touch IC jobs, but not anymore. If it's something that you can't solve, that if you continue to get annoying issues like that, change your angle, and then after that you can start kind of digging out ahead of time, the silicone that kind of traps those components. If they don't have anything around them, they'll be able to breathe and just be fine on the board. So that you can kind of resolve that like that. How many times do you do microsoldering while cooking? Never, because I'm at work. And for cooking, we have a microwave. So never. How much should I charge for a repair like this? I don't know. What is your fee for not charging solution? For us, it doesn't matter that we had to go find a short and that this thing has now consumed 3 Tigresses, 2 Tristars, which is a chip cost of whatever it is, let's say $15 that went into this board just for troubleshooting. It doesn't matter. It's a flat rate solution. So same as if it was just a straight up Tristar job. If it's on a power supply output, different capacitances can filter out different switching frequencies. Yes, we learned that in our data sheet on the way the little charger chips work. All right. All right, here, we're gonna make Jim a mod for being a good sport. And that way he can delete, if he feels like it, things like it's the coil, which is no longer funny in the least. Is it okay to use some flux and remove a shorted cap with just a hot iron? Yeah, that's what I just did. Okay, so let's see what the deal is. Let's see what the deal is now. All right, let me look over here. Let me close that off. All right. Okay, so let's see what the deal is now. It is time to test. And I'm going to be bummed out, and if it doesn't charge, which if it doesn't charge now, then my conclusion would be same way that Tristar got damaged in a situation with this 5-volt chargers. That PMID line is on 5 volts, which means it's a variant likely of the actual incoming charger voltage. Then I would be suspicious of Tristar and anybody else that's on that line. But let's see. Sometimes you just have a simple problem. Let's see. Let's go big or go home. Let's put a screen on it. Or what do you guys think is going to happen? What's your prediction? Okay. Let's put this so that you can see the result, same as me. I always think it's cheating when you do a repair and that might not work. Let's see. I'd like for us to all find this out together. Maybe I can make that happen. I don't know. Can you see blue? How about if I do it like this? How about if we go extra double janky and do that? And if we raise that up, can you see that? Kind of. All right, here we go. The moment, fuck! The moment of fuck. All right, super gentle. It's got a battery, it's got a screen, and we're gonna prompt to boot. And I see the charger reacting. And what's it doing? I can't tell. Yay! Charging! Huzzah! Stay charging. Normal charging. Yay! And it's booting. Hooray! All right. Now let's see if it actually shows a lightning symbol and then the day will be saved. Hooray! All right, so let's disconnect this so that we can reconnect it, and hopefully it will. What's this dude's passcode? I would like to see his passcode. All right, so I'm going to kind of let this hang out for a second. It says 15% charged right now. And it is pulling normal charging current. All right, so 15% charge pulling normal charging current, and I think that it is going to be solved. Let me see if it's, I would not expect it to be getting hot, so I'll use the face detection method again. And it seems kind of like normal heat. Awesome. All right, so I'm gonna let it hang out with that battery for a little bit and see if it can go up a couple percentage. And I will check in on chat, and then we will call it a day. All right, so let's go back and see where I left off. We talked about how much do you charge for this, same as any other repair, it's flat rate. How could a short VCC main kill the Q1402? I don't know what the Q1402 is. Let's see. All right, more spam. You got modded, run! Let's see. You should look for some information about microwave. Water inside food is disposed to high frequencies, so what? And causing food to fall apart, so what? And you are eating completely death food. What? How does water molecules that get hot equal death food? That doesn't make any sense. Use your brain. Think about it. Does that make sense? Or does that seem kind of crazy? And getting cancer. You really need to, I mean, I know a lot about cancer. You tell me, how does a microwave frequency cause water to, what did it say? Make food fall apart. You show me how that's going to mutate a gene. All right. Microwaves gives you cancer. All right, I would check for shorts before plugging back into power. We did. It's going to work because it's 10:30 p.m. and I need to get some sleep. That's right. We need to see the smoke. Ain't going to be no smoke. Hold it in your hand. That's what she said. You need a glue. We solved it. Congratulations. Woo. Shouldn't it charge to 2 amp with the iPad charger? What does an iPhone do? No, it should charge. It depends on the battery. The battery, and it depends, on the state of charge of the battery. And 1 amp would be that. Let's see. Oh my God! Every time I decide to watch it work, she yells "fuck." Sorry about that. If Jessa wasn't so awesome, I'd have to quit. Is there a way to diagnose U2IC with a multimeter instead of guessing? That's a good question. The answer is not really. You can look for power short or a diode mode reading that's off on the components that are really bringing the power to the TriStar IC. But for most of the tests that you would need to do to investigate the data lines, and that chip is 99% data lines, you'd have to lift the chip in order to tag into those balls. So in which case the diagnostic for most TriStar issues is replacing TriStar. All right, is anything getting hot? Nope. Seems good. You should stop using your phone and Wi-Fi if microwaves give you cancer. Water and sunlight are the biggest cancer causes. That is true. And so is this stream. I have a problem with the camera on my iPhone 6s Plus. I don't know about that. That's not what we're talking about. It will draw the current that it needs. Yes, slide D's. He knows what's what. All right. The device will pull the amount of current that it needs. Okay, let's check. So it was at 15%, and it is still, as it kind of sits here, it is still pulling what I call normal charging current. It's more or less 1 amp. So we've got normal charging current, which is more or less 1 amp, 0.74. This battery is, I think, pretty dead and beat up. And we are gonna call that one fixed. So I'm gonna get out of here, and I will see you guys on the next stream.